Had my hideous cup of coffee, bowl of cereal. The reign of terror continues. About an hour from now, I got to go do my hideous walk at the mall. So I only got time, I think, to work on putting this guy to bed. I'll start with the cylinder. Notice the condition of the cylinders. I got the after motor bulkhead with the attached devices and the forward bulkhead where the battery goes apart from the cylinder. That's the way I put my cylinders away for at least a day and a half after a mission where they were in the water. Even if there's no water evidenced in the cylinder, I'll do this anyway, just in case some water, a little bit of water got past the seals or anything like that. I want to give it an opportunity, usually under a heat lamp, to evaporate. And this has been like this for a week, so it's in good shape. So I'm just going to lube up the cylinder ends and then put the bulkheads back on. This is the work I did this morning. It's still gooey. But looking at the depressions, which represent the flood and drains, they're completely full. There's no voids, no bubbles. Looking good. So probably this afternoon, because I haven't used any heat lamps on this. I might put it on heat lamps before I go for the walk. And the next coat will go on. It'll be an entire cover that time, but it'll be just enough to wet it out. After that second one, the complete start of the glove, then I will use thickened rubber and start really building up the thickness. I should have that work done in 2 days. Of course, that's part-time work. Whenever it cures, I come back and lay another layer. I'll cover this in detail at a later date, but this process you're watching here was the creation of a tool from which fiberglass hull pieces will be later produced. It's basically laying in a rubber glove and then over that a case, and then reinforcing everything with an egg crate. And then finally, you wind up with a tool you can use to lay up fiberglass hulls. Pretty slick. All right, back to this guy. So I use silicone grease on O-rings because O-rings, being a rubber end, is easily attacked by hydrocarbons, which is your typical lubricant, whereas the silicone is not and will not over time degrade rubber. So that's why I favor using this stuff. There we are. You notice I put it in the cylinder and not on the O-rings proper, because these are sitting outside. And of course, the sticky lubricant acts like flypaper for sand or any grit that might be around. So I avoid, like the plague, putting silicone lubricant anywhere that might catch sand and stuff like that. So assembling this thing is basically, just jam everything in there as best you can without suffering interference. Notice the care I'm taking with this. Assembly. I put it in there and I make sure that none of the wires are caught on that bulkhead. I don't want to be cutting wires. And then I check the orientation as I push things in. You see a wire hanging up there? That's how tight it is in there. While I'm doing this, the bus wire, which gets all of the battery current to all the devices in here, see that wire? I'm pulling the slack out. It's going through a conduit which maintains watertight integrity between the ballast tank and the dry spaces. So I'm pulling out the slack as I install the motor bulkhead. Okay, that's going pretty good. I'm checking for fouling. I don't see any. We don't have anything hanging up there. You see these index marks right there? I'm going to line those up. One last tug on this to get any slack out. We check the O-ring all the way around, make sure that no wires or anything hanging out, and then we push. And final alignment, and that's that. Now, before I button up the forward space with its battery, you notice I have two of them. These are lithium-ion batteries. Jake put me onto these because he's very phobic about lithium polymer, as I should be, in that I had a house fire not too long ago because of those batteries. Thank you very much. So I make up the battery. Now I have two switches. One is a emission switch, which is for the system, and it puts current right on the bus here. And then in parallel with the battery, I have another switch, which is for the lights, which I'll demonstrate later. But right now, the lights and the emission switch are off. We're all hooked up. And before I put anything in here, I want to make sure I didn't screw this up when I put it in. I want to make sure everything works. Okay? So I'm going to take the transmitter, turn it on. Anyway, transmitter's on, and then I go over here to the emission switch, and I turn it on. Look for the idiot lights when I do that. See that? Center the throttle. Now we're going to check the rudder servo. And what would be the stern planes is actually a gimbaling propeller. The rudder, incidentally, is also gimbaled in yaw, and the propeller is gimbaled in pitch. And I can do a collective or do them together. And there you have that. This third servo is just a redundant one. It's not in use. Normally that would go to bow planes, but there are no practical control surfaces on the Disney Nautilus. So we achieve pitch and yaw control using a gimbaled propeller. And we'll check the motor. Now, post-mission, when I took this out of the water after an initial trim trial, I found that this was leaking at the seal on the motor shaft. I took it apart and found out that I had used an old-style iron-based oil-light bearing, which had rusted over the years and contaminated the cup seal. All right, so I'm happy with everything. Check the ballast system. That's the pump. The pump is right there. And this, of course, is the ballast system servo. That's the vent position. This is the blow. There you have it. We'll turn the emission switch off, turn off the transmitter, and we're ready to put this dude into the hull proper. Before I do that, I'm going to get the upper hull out of the way so I don't cream anything. There we are. All right. So, I use Velcro straps these days. Used to be rubber bands, but these are a lot easier to finagle. Of course, this is used to secure the cylinder in place. But registering the cylinder so it doesn't move longitudinally or radially is this indexing pin, which fits into a hole right here. Okay? Now, the only thing I have to do to get this going is to line up the propeller shaft with a flat here and push it into place. There, like so. And then I rotate this until the indexing pin is happy. Set screw. And I'm going to make sure it hits that flat by slightly rotating the propeller. Okay, that's made up. The propeller is secured. And I think we're good to go. So all I have to do is now make up this Velcro strap. There we are. So we have the cylinder an integral part of the hull now, and it cannot move longitudinally or roll, and that's what we want. So in this condition, we want to do another test. And it's the same as before. Turn on the transmitter, and then turn on the mission switch. And here I can demonstrate the yaw and the pitch. This antenna is sometimes problematic, but you can get it out of the way, like so. Yeah, see that thing just pop up just for spite. There's the lights. Okay. Of course, the upper array is not lit because we haven't put the top down to make electrical connection here. And we'll do that next. Turn the mission switch back on. Mission switch, light switch, duh. The lamps around the salon big window, they're lamps behind the lenses which represent the housings that you see externally that circle the main salon window. The lamps themselves are LEDs, old style, that required dedicated current limiting resistors, and each one got a current limiting resistor. They were all wired in parallel and were fed by the main line current, which was 7 volts, and that of course was dropped to a voltage and current level that these things could handle without burning out. So the one function switch that I showed you, we had 2 switches, one for main mission and the other for the lights. Well, they're both discrete circuits and come off of the battery. So that's how those lights work. Not that big a deal, actually. So, moving on here to other things. All right, make sure nothing is going to foul when I put the upper hull on. I have to take care to engage that pin into the bearing in the upper portion of the vertical stabilizer. You can just see it there. Start there, get that guy engaged. At that point, it's a simple matter just to press this down until this little stud, you can just make it out here, evidences. And we press the hull down, and we start at the bow. Seeing how the ram fits into a tube which is in the lower hull, as you can see that there's 2 diameters to the ram. The smaller diameter fits into that tube and then extends a little bit farther aft, and you can see in the upper hull to the left there a little ring which is secured within the upper hull, and the after tip of that rod inserts and secures the upper and lower half of the bow in place. We're using the ram itself as a locking element for the bow, and within the little skiff, Nemo's Ride, there's a little hook arrangement here. So when it engages a groove in the stud here, you can see at the bottom of the skiff has been attached a brass piece. It looks like a fork. The fork engages grooves at the top of the stud, which, as you can see, is secured to the lower hull. So when the upper hull is placed on top, a hole in the well where the skiff fits, it permits just the top of that stud to stand proud and the groove to be engaged in the bottom of the skip when I slide the skip forward into that groove. And then, of course, the skip itself does the work of holding the upper hull down on the lower hull. There's a little hook arrangement here, so when it engages a groove in the stud here, I push the ass end of the hull down, I run it forward until that hook engages, and that locks the ass end down, so the front and the rear are secured, and the model is active, and we check that. Rudder. Oh, I gotta adjust that rudder, that's awful. I'm not gonna bother right now. Yeah, we'll do something with the rudder. But the pitching control is working. Now what I'm going to do is I'm going to pick up the model. It's got an angle keeper driving that propeller. You can just see small motion and pitch of the propeller as a consequence of angular displacement of the model. All right, so we're all set. And now what I'm going to do is I'm going to pick up the model. It's got an angle keeper driving that propeller. You can just see small motion and pitch of the propeller as a consequence of angular displacement of the model. All right, so we're all set, and there's one thing I forgot to do. So we got to do it all over again. I didn't make up the hose that goes up into the wheelhouse. You notice I've left the navigation table back transparency off. That's where air comes in. Once the sail broaches the surface, and this in submerged trim, it's trimmed to float with just that much of the wheelhouse above water, so that the end of the snort tube can grab air when I want to empty the ballast tank. You can see how that works. Still got to get that rudder in sync with the propeller, but you can see, hopefully, to advantage, how that gimbaling works. All right, good enough. Seems like the pump is working. Now we put the beast in the water. And we wait for things to settle. All right, so what I'm doing now is I'm opening up the vent valve. And down it goes. Now there's still some surface tension at work there, so I just gave it a little bit of a push. Now holding the vent to make sure that there's no air at all in the ballast tank, I'm just going to rotate it and do this and shake any stubborn bubbles that remain in there. And we wait. And probably because that's a new battery, and even though I was careful to get its weight right, you can see that water line is where I want it, right there. So that means the snort tube is above water, so once I go to blow, it'll draw air from atmosphere. As a practical matter, on this small model, these control surfaces are strictly for looks. They don't work. Incidentally, this is the Scott Brodeen kit, which was never designed to be RC. It was a display piece. And he rotocast it, which fortunately rendered a hollow hull, but very, very, very thick wall thickness, which of course results in a great deal of displacement, particularly above waterline. Now, I put this thing on a milling machine and ground a lot of that material back from the above waterline areas. so I could reduce the volume requirement of the ballast tank, and that's what I came up with. I don't know, between 3 and 5 ounces of water in there, and that was enough to get this model in its current form to the design water line, which is right about here. Okay. All right. Enough yuck yak. I'm gonna go do my hideous walk. So this is good. I want to make sure the switch is off. Nothing else going on. Fine. Blah 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 blah. Well, another day. See, I got Howard coming in tomorrow. So, got to do the yard, finish cleaning the house. Anywho, I'm just finishing up what I thought was going to be just a simple validation of the work needed to do a final trim, and then I found a bunch of little problems, mostly with the rudder, the linkage back here. I don't know if you can see it. This item right here. The control rod here was making interference, so I had to build a new horn. And I found I needed just a little bit more foam to get it in proper submerged trim. And the only place I could shoehorn that foam was right here. This little piece here, which had to get by the linkage for the shaft and the tilting mechanism for the propeller. Anyway, I made some adjustments. The last thing I had to do was tighten up the vent valve a little bit, and that's been resolved. So one more time, we're going to put it in the water. So I'm turning on the transmitter, turning on the mission switch. Make sure everything's alive. Yes, it is. You can see to advantage now the mechanism used to yaw the propeller and the rudder, and the pitch the propeller. There you go, like that. Give it a little throttle. Whee! You can see how that works. All right. So to make this thing ready for sea, all I have to do is make up the snort tube from the that extends up into the wheelhouse here. That's what this hose is. So the pickup is right up here. And of course, the wheelhouse, like everything, is free flooding, open to sea. And once you broach the wheelhouse, you have a source of air to blow the ballast tank when you elect to surface the boat. So I'm making that hose up, the snort hose, the induction, from up here in the wheelhouse. It goes into this manifold, into the cylinder, into the pump. The pump discharges the air here into the ballast tank, forcing the water out. So it's a proper static diving system. All right, putting it together is nothing more than making sure that the rudder bearing engages the operating shaft. And you can see the hose there is going to give me a little problem. So I just set it down, and everything fits nice and copacetic. So I make up the ram, which secures the front end, and this latch here, which engages the stern. If I can get it to make contact. And for some reason it's electing to give me a hard time here. There we are. Got it. So that little latch is holding the stern down. The ram is holding the bow down. And with everything put together, one more time we play with it. Make sure everything's working. As you can see, we've got plenty of rudder throw. There we are. So now we're going to put it in the water. And just to affirm everything's working. And once I'm happy with that, I'll put it to bed. We've got the Norfolk Harbor Fest coming up next weekend. It's Sunday now, so I'm about 6 days away from that event. No, 5 days. It's on a Friday. So that's normal surface trim. It's a little low in the ass end, but the skiff is right at its water line, which makes sense. It'd be easy to launch and recover in this trim condition. As you can see, the wheelhouse and forecastle is well above water. So it looks representative of what we saw in the movie. So that's not bad. All right, let's go ahead and make this thing work. I'm first going to go astern a little bit. Put a little rudder on, go astern. Going ahead. See how it pitches? Even in this very short distance. Not pitch, but yaw. All right, we'll kill our headway. All right, so we open the vent. A little stubborn there. And that's our normal submerged trim. As you can see, the wheelhouse is submerged except for this upper portion here, and that's where the induction hose starts, right there at the top of the wheelhouse. That open little window there that leads to the chart table. Well, that's open for a reason, so that air can get into the wheelhouse and into the induction, and you'll hear that when I start the pump. I start to pump, the air goes in the ballast tank, blowing out the water, and hear all that bubbling in there? Good. We're now in surface trim. There we are. All right, I'm happy with it. So we'll put this guy to bed and put it in its box, and we'll be all set for the event. But I will perform post-mission on this because it's going to be sitting for a week, and I want to make absolutely sure that no water got into the watertight spaces of the cylinder. So first thing we'll do is open this up, turn off the mission switch, take the cylinder out. So you can see the operations is simple. You just lift it up, undo the induction, lay this guy down. And now, to remove this thing, there's only two things I have to do. One is loosen the connection to the propeller coupler. couple of turns on that screw there. Loosen, might as well just remove the Velcro strap that secured the cylinder to the hull. Get these magnets out of the way. One for the rudder, one for the pitching mechanism. Pull out the cylinder, and there we are. Take a quick look. I don't see any entrance of water, but that doesn't mean anything. If you got a couple of drops of water past, now let's turn this guy off. Boom, boom. If we got any water past there, you wouldn't know it. It would still be hung up in those little cavities where the seals are, and that just that little bit of moisture would turn things into a tropical forest. Yeah, there's no evidence of water. Now we're happy with that. But to put this guy to bed involves removing the forward bulkhead and the battery. I'm going to put that on charge, even though we haven't put much of a load on it yet. So there's your battery. Okay. Then we pop the after bulkhead and we pull out the equipment, the devices and everything. If I had any leaks at all in those seals, it would be right there, and I don't see anything. You wouldn't see anything in the motor seal. It would just go right into the motor. So I replaced that seal just the other day. It should be good. But then again, caution is the word of the day in this game.